We are on to chapter 9, so we've talked a lot about the normal distribution. I'm getting z-scores so we can use that normal distribution to find all of our different probabilities. So let's start kind of a motivating example here. So we had a poll that asked 1,783 registered voters whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. Obtain a point estimate for the proportion. What am I asking you to find? P hat. You know P hat is X over N. How many said they were in favor of it? Out of how many total we asked? Okay, and you have to do that. So we get a point estimate of 0.6298. So then my question for you, does this mean that most people are in favor of the death penalty? In this sample, what if I'm asking about like nationwide? Are most people in favor? Is this convincing enough to you to be certain that that's true? No. It tells us that in this particular sample, most people did, but we don't know for sure. There is variability in samples. If we had a different sample, would we get a different p hat? Probably. Each sample will likely be different. And so that's why if you are ever like watching like political polls or anything, they don't just give a specific number. They don't just say, oh, 43% are in favor of this candidate. They say between 40 and 46% are in favor of such and such candidate. They give a range. So to be more accurate, we need a range of values. Because even if I had a really, really good sample, and I got another really, really good sample, I would probably still have a different p hat, okay? Just because it's not going to be the same every single time. So what we are talking about here is what's called a confidence interval. The confidence interval is basically a range of values you build around your point estimate. The level of confidence tells us the expected proportion of intervals that would contain the parameter if a large number of different samples was obtained. So it's typically as a percent, so like a 95% confidence interval means if we went and we made 100 different confidence intervals, then we would be confident that 95 of those would include our true value. Okay, so if I say I'm 60% confident, that means if I built 100 intervals, 60 of them would contain the true value. Does that make sense? So it's basically how confident we are that our value would be in that range. So to get that, the confidence interval is always centered around our p hat, our proportion, and it's basically our point estimate, and then we add or subtract some level of error. So to get that margin of error, that's going to depend on how accurate our point estimate is. If we're not very confident in our point estimate, we're going to have a pretty wide range of error. If we are very, very confident in it, then we might have a small window of error. So some things that would impact our error level of confidence, as your level of confidence increases, so does your margin of error. Okay, if I want to say I am 99% confident that my value is in there, we're probably going to need a little more error to say that 99% of them would include it. But if I only want 75%, I can make it a smaller window and still capture the true value 75% of the time. So the higher the confidence level, the higher your error. Sample size. We know as we get bigger samples, does our data get more or less accurate? In general, the bigger your sample, the more accurate it will be. Just because if I only asked you guys, okay, that's just a very small number of people. And I was trying to make an assumption about the entire adult population in the United States. Just asking 10 people is not very accurate. So the better you want your data to be, the more people you need to include. So as we have a bigger sample, that would decrease our error because we'll get more accurate by including more people. Standard deviation. Remember, standard deviation measures how spread out the data is. And what does a big standard deviation tell us? Yeah, it's not consistent. It's really spread out. So if we have a high standard deviation, we're going to have a higher margin of error, just because the data itself is more spread out. So the more spread, the wider our interval will have to be. All right. So essentially, we're kind of narrowing it down. We know we're going to be creating an interval of values. Our point estimate is at the middle, and then we'll have to add or subtract some level of error with that. We're talking about p-hats today, so remember when I'm talking about p-hat, what were the criteria? The sample has to be less than 5% of the whole population, and the mean for my p-hat was just our population proportion. Standard deviation for p-hat is the square root of p times 1 minus p over n. So we're talking about p-hats today. We'll still have to be able to check our criteria, even if we're just building a level of confidence. We have to have criteria with that. So the formula, we have a lower and an upper bound. It's really the same thing, except to get the lower bound, you do your point estimate minus something, and to get your upper, you add it. If you look on your formula sheet, it doesn't break them apart. It just says it's p-hat plus or minus, and leaves you to realize that the smaller one you'll get by subtracting, the bigger one you get by adding. So that is on our formula sheet. Criteria still have to be true here. So when we make these confidence intervals, it means we are whatever percent confident the true value is between the upper and lower limits. Okay, I told you we're essentially adding a margin of error each time, so this expression that you're adding and subtracting, that's referred to as the error. So we do the z alpha over 2, p hat, 1 minus p hat over n. Where have we seen the square root of p times 1 minus p over n before? Standard deviation for those, except in this case we're using the p hat instead of the p value. The z alpha over 2, we haven't done z alpha since chapter 7. But remember, that notation is finding a z value on the table. So it goes back to that normal table. The difference is when you see that alpha, it's the opposite. So your table gives you everything less, that alpha is talking about greater than. So we'll refresh how to find those on our table. Any questions so far? So let's actually try one. So going back to our hole that we already found, I want to build a 90% confidence interval. So we already found an example one, the p hat. Turned out to be 0.6289. Before we do anything else, we have to check our criteria. The sample has to be less than 5% of the whole population. Would 1,783 be less than 5% of all registered voters? Second one, we need to check n times p times 1 minus p greater than 10. So if we do that, our n was 1783. P, in this case, we have to use the p hat. We don't have any other p values given. So that's definitely bigger than 10. So that criteria is met. So far, so good. So now we need our z alpha over 2. Alright, so look at your normal table. Excuse me. What we're trying to do is build a 90% confidence interval. So we need 90% of our data to fall in the middle. Okay, that's why the alpha over 2 comes in. We have 10% left, but how much do we want on each end? 5%, so 0.05. So that's the alpha over 2 piece. We have 10% left over. We have to divide it between the two ends. All right, there's a couple ways to do this. We are looking for our z values. Okay, now technically there are 2 of them, right? A positive and a negative one. We're just going to look at the positive one because the formula itself, the negative is the minus is for the negative z value, the plus is for the positive. So if we just look up the positive, then we can use our formula. So we're basically needing to know what is z so that 95% of the data falls below this. Alright, so you are looking inside your table to the closest we can get to 0.95. Alright, what'd you say? 1 point. Yeah, because if you look, 1.64 is 0.09 or 0.9495, and 1.65, 0.9505. So it would be right in the middle of those. So 1.645. Does everyone understand how I got that z value? I want to draw your attention to something. If you look at the bottom of your chart, the bottom corner, it tells you the confidence intervals for the common intervals, so 90, 95, 98, 99, it actually gives you the Z alpha over 2, which that's what we just found. But I don't want you to only rely on that because I could ask you any confidence interval, not necessarily those 4. But just, if I do ask you one of those, you're welcome to look there to get it. All right, so my confidence interval, if we look at our formula, is p hat, which we got 0.62, is it 98 or 89? Did I transpose my digits? 98. Okay, I did up here. Sorry about that. Okay, plus or minus Z alpha over 2, so 1.645. And remember guys, this is just straight from your formula sheet, so you're just plugging things in. So times the square root of p hat 1 minus p hat divided by n, and what was our n here? So now we put all this in. Just do, so 0.6298 minus, once you type in a minus, you can just hit second enter and bring it up and do the plus. Did you guys get a lower limit of 0.611 and an upper limit of 0.6486? So typically, I could say what's the lower and what's the upper. Lower is just your smaller one, upper is the bigger one. More often though, we just actually write it as an interval at the end, so just like this. And so what that means, and I think, did I give you guys a blank slide after this? Okay, so you can use that if you need to. It means we are 90% confident the value is between these numbers. Or the value in this case is the number of registered voters who believe in the death penalty. So we are 90% confident that the true proportion is between 0.611 and 0.6486. So somewhere between 61 and 64%. Is that one okay? It is very windy out there. Feel bad if you have track practice too. Alright, a Gallup poll found 54.9% of those surveyed considered the amount of federal income tax they pay to be fair. Gallup reported the following survey methodology. Results are based on telephone interviews of 1,016 national adults aged 18 or older. For results based on the total sample of national adults, one can say with 95% confidence that the maximum margin of sampling error is 4 percentage points. determine and interpret the confidence interval. Okay, so we're not even really calculating the confidence interval here, we're just writing it. They have already found this initially, and they said that their error is 4%. What confidence level are we using? So we are 95% confident the proportion of adults who believe the income tax they pay is fair falls between. Okay, so they don't really think it is exactly 54.9%. It's within 4%. So if you go 4 below that, that would be 50.9, or if I did it as a decimal point, 509. And 4 above it would be 0.589. So that's what that confidence interval is telling me. 95% confident that the real value falls between those two numbers. All right, I want you guys to see if you can set up this next one. So take a couple minutes, see if you can set. All right, so did you guys check your criteria? And those are satisfied. P hat, did you get 0.34? So Z alpha over 2, if we want a 95% confidence interval, that means 95% is in the middle. So how much is left for the ends? 2.5%. So if you're looking it up in your table, you have to find the Z so that 97 or 0.975 is below. Does that make sense? So you're looking in the middle of the table when your area, so the number in the middle, is as close as it can get to 0.975. And that is actually an exact one on there, 0.9750. And the Z that matches it is 1.96. That was also one given on the bottom of our table. So everyone knows where I got my Z alpha over 2? So now we do our formula. It's our P hat, so 0.34 plus or minus the Z alpha over 2, 1.96, square root of P hat, 1 minus P hat over N, which was 800, .3072 for the lower limit, and their upper of .3728. Did you guys get that? So what that means is we are 95% confident the proportion of 16, 17-year-olds who have texted while driving is between these two numbers. Okay. So I want to see what happens if I change it to 99%. And we're actually I'm going to show you another option here. So this was, we just did the 95%. I'm going to write it down again because I like it all on one slide when I'm looking at it. 0.3072, 0.372. Now we need the 99%. What should happen to our interval if we're going to be more confident? Yeah, the interval is going to get wider. Okay. We can use our calculator to get these as well. So you are going to go into your calculator. So we're going to go stats, tests, okay, and we're going to have to scroll down. We want letter A 1 proportion Z interval. We had one p hat value. It's a Z interval because we're looking for Z values. Okay, so stat test letter A if you're jotting this down. Once you do that, it's going to ask us 3 questions: X, N, and our C level. So X, we used when we did p hat, X was 272. N, how many did we have in our sample? 800. And what confidence level am I looking for? Okay. So we have X, 272, N, 800, confidence level 0.99. And then we'll calculate. And it gives us that our interval is between 0.29686, 0.38314. If you want to check our first interval that we did by hand, we could do it again. Stat, test, letter A. The X and N are the same, but the first time we did it, our confidence level was 95%. So if you did 0.95 here. Is that what we had? Yeah. So we can use our calculator on these as well. Any questions about how to do that on our calculator? And so, were we right about what would happen to the interval? Yeah. We have a wider interval since there is increased error. The last thing we want to look at. So we've been talking about making a confidence interval. And we know that if we want to be more accurate, what do we need to do to our sample size? The bigger the sample size, the better our data will be, right? But there's limitations on that. If you're doing a study, the more people you include, what happens to the cost of your study? It gets more and more expensive. So you want to have enough people, but you don't really want more people than you have to. Okay, it takes more time, more money, and it's not ideal. So the last piece of this is talking about how big of a sample size we need. Sorry, I forgot I had this example. I'll come back and do that one in a second. Okay, so this is, again, like everything else, on your formula sheet. It tells you a way of calculating how big your sample size needs to be. And there's two options. This one is where we have some prior estimate of our proportions. So maybe there was a study done 5 years ago, and we can use their value. You'll notice it's all things that we're using, p hat, n, z alpha over 2. What do you think E stands for? The error, which we wrote down on that one slide, it's the thing we add or subtract. So if I wanted to do that one, I have to have a prior study. If I don't have a prior study, we just do this 0.25. So there's 2 bullets on this, on your formula sheet under sample size, and it tells you how to do both of those. So let's look at these 2 examples, and I'll go back and do the one I skipped. I just want to make sure I get through this. So a sociologist wants to determine the percentage of residents of America that only speak English at home. What sample size should be obtained if she wishes her estimate to be within 3 percentage points with 90% confidence, assuming she uses the estimate obtained from the census of 2000 of 82.4%. So do we have a prior estimate? Yes. So we're using that first formula. So the number we need is our p hat, 1 minus p hat, z alpha over 2, divided by e squared. So our p hat is the 0.824, the prior study. Okay, z alpha over 2, so that's 90% confident. So 90% in the middle, that means 95 below. We'll use this one already today. It's on the bottom of that chart. What is our z alpha over 2? Okay, error. How much error am I allowing? 3 percentage points, so 0.03 squared. Alright, so if we type this in, so we get 436.04. Okay, we can't ask a partial person, so either you talk to them or you don't. Would 436 people be enough? No. So on these, you always have to round up. So we'll have to go with 437 people. Because if you have only 436 people, there's not enough for this error. So in order to get within 3%, you need 436.04 people, so the 436 was not enough, and you can't have a partial person, so always go up. Okay, so if we didn't have that prior sample, we have to use the second formula, which is the 0.25 z alpha over 2 divided by e squared. So my z alpha over 2 is still 1.645. My e was still 3%. And this time we get 751.67. So this time she must survey how many people? If you don't have a prior survey, it's always going to increase our n value. Any questions there? one problem I skipped. Find the point estimate of the population proportion. So I'm looking for p hat, the margin of error, and the number of individuals in the sample. Sorry, with the given characteristics. So I'm looking for x. Okay. I have given you kind of the results, the upper and lower bound. We know that when we do this, our lower bound was 0.051, the upper bound is 0.074. The middle, we build all of this around our p hat value. How do you find the middle of those? How do you find the middle of two numbers? Add them up, divide by 2. Okay, so our p hat is 0.0625. So, a confidence interval, it's like your center, and you either do something plus a margin of error or something minus your margin of error, right? So how would I find that margin of error? Yeah, you subtract a couple different ways, but we just basically need to find out how far apart two of these are. So I could do my upper bound minus my p hat, or you could do p hat minus your lower bound, which you get the same thing. And so our error is 0.0115. Okay, so far so good? Can you figure out any way we could find x? Plug it into what formula? P hat is x over n. But p hat was 0.0625 and n 1,120. So multiply over the 1,120 and we get 7. Vicious. Okay. I know this was a longer lesson. I have, just like we've been doing for the other chapters, I have one assignment for section 9.1 and 9.2. So tomorrow, 9.2 is also likely going to take me a little bit. So I'm giving these to you, the game plan. I know we have a massive break, which is not ideal. So we will come back on a Tuesday. That Tuesday will be a work day for all the chapter 9 stuff because I'm not giving you very much in class time to work on homework the next 2 days. So start it. You have 10 minutes right now. You can do some of it, but don't feel like you have to take it home and work all night trying to finish it up. Okay, tomorrow once I finish you'll have some time, and then that Tuesday you'll have the class period as